So today we will study about the next thing which comes under the gravitation topic, right? And basically this topic is related to the force in a liquid, right? So this is your buoyancy. Okay, now before understanding buoyancy we have to understand what is upthrust, or also called as buoyant force, right? See, the definition states that the upward force exerted by a liquid on a body which is immersed in the liquid, okay, then that force is called as your upthrust or buoyant force, and is called as upthrust or buoyant force, and the phenomenon is called as buoyancy. Okay, what do you mean by this statement? Say for example, we are taking a beaker, okay, or a container, and we have filled a beaker with water or any liquid, okay, right? Now this is one object, right? When we will measure the weight of this object outside this liquid, this is for example say W1, okay, the weight of the object outside this liquid is W1, right? Now what you have to do, take this object and dip it inside this water, right? Now the object is here inside this water. Now when you will measure the weight of this object, right, then the weight of the object, say it is W2, okay. So when we will compare the reading W1 and W2, we will see that W2 is less than W1, although the object is same, right, but the weight is coming less in water with respect to this object when it is in outside position. Why this is happening? Because according to this statement, when we are dipping this object inside this water, then this liquid is experiencing or exerting a force which is upward in direction. So this F1 force is coming into play, okay, and which is exerting force upward. So this F1 force is reducing the weight of the object. That's why W2 is less than W1, and this F1 force, this is your buoyant force or upthrust. Okay, now how you will calculate the value of this F1 or buoyant force? See, F1 in this case, or F, you can say F will be equal to V rho into G. Okay, this is the formula for calculating the upthrust or buoyant force, right? And what is this V, rho and G? V is nothing but the volume of the object, okay, volume of this object which we are dipping inside the liquid. Rho, this is called rho. Rho is nothing but, rho is the density of the liquid, okay, and G, small g, you are familiar with this small g. I have already mentioned the complete details about small g in the last video, okay. So that small g is nothing but your acceleration due to gravity. Alright, so by using this formula you can calculate the value of buoyant force, okay, and as the buoyant force is force only, so the unit will be your Newton. Clear? This is the concept of a buoyant force. Alright, now come to the most important significance of buoyant force. Okay, see, buoyant force is the criteria due to which the objects float or sink inside a liquid. Okay, now see, floating of object, this is a topic, floating of object. This depends on the buoyant force exerted by the liquid. Okay, now see why this is happening, because in case of buoyant force, the buoyant force changes, alright, but the weight of the object at any specific place, that is not changing. Why? Because weight of the object W is your m into G, right, and mass is a constant, so mass will never change, only G can change, which I have already told you in the last video. But when we are performing this experiment or we are doing something, then at that specific place the value of G will not change. So m into G, this condition, or it is called as your weight, so weight of the object is not going to change. right? So the object will either sink or it will float or whatever be the situation inside the liquid. That completely depends on your buoyant force, right? So how you will decide that whether the object we are immersing in the liquid, it will float or sink or whatever it will do? So for that we have to do a simple experiment. See, we are taking 3 containers, okay? Each one is filled by liquid. This is our liquid, right? And this is our object. 1, 2, 3. These are 3 conditions, A, B and C. Okay? Now see, in this condition the object is completely dipped inside the liquid or immersed inside the liquid. Why? Because here weight of the object is greater than your buoyant force. Whenever W or weight of the object is greater than F1, F1 is your buoyant force and W is your weight of the object. Okay? So whenever W is greater than F1, then the object will completely come to the bottom of the container. Okay? Second condition, if weight of the object is less than the buoyant force, it means the upward force is more than the weight of the object. In that case, the object will float in this condition, in this way. Okay? It will come at the surface of the liquid. Right? Now the third condition is when weight of the object and the buoyant force are equal. Right? When both the forces are exactly equal. In that condition, the object will float like this. It will only, the top of the object will come at the top of the liquid and the object will float in this way. Right? So by knowing just the weight of the object and the buoyant force exerted by the liquid, you can easily tell that whether the object will sink inside the liquid or it will float on the liquid. Clear? So this is a very simple experiment and it is very useful for deciding. Right? So this is all about in this floating of object topic. If you find the video interesting and helpful, then like the video and subscribe the channel and share it with your friends. Okay, thank you.